Lesson 64, Semicircles. This is a rather difficult lesson, so make sure you follow along, you're fully paying attention. So we're going to talk about semicircles. So semicircles are half circles, and we are going to find both the circumference of them and the area of them. So if they're half circles, we're going to find the circumference of the entire circle and divide it by 2. There's two different ways to do this. Circumference, the formula for it is circumference equals 2 pi r, or you could say the circumference equals pi times d, the diameter, because two radii equals the diameter. Now we want a half, it's going to be the arc length of half of a circle, which we call a semicircle. The length of this arc is called the arc length. So to find the circumference of a circle, we take of a semicircle, we take the circumference of the circle and we divide it by 2. So we can use the circumference of a half circle, let's put a little half there, is going to equal to pi times the radius. Or we could take the diameter times pi and divide it by 2. I prefer this way to find the semicircle. You just take pi times the radius and then you don't have to divide it by 2. Okay, that's the circumference, that's the arc length. Now the area is all the shaded in part. So let's remember the area of a circle. So the area of a circle, and this would be half a circle, the area of a circle equals pi r squared. We're going to square the r because it's more space. Now if we want to find the area of a half a circle, it's going to be pi r squared, there's no easy way around this, divided by 2, and that's going to give you the area of a half circle. So it just makes sense. You just find the circumference of a whole circle, divide by 2, the area of a whole circle, and you divide by 2. I'm going to make an exception to this. I thought about this for a while. I'm going to let you use your calculators for this lesson alone. So you have to use self-control not to use it any other time. You can still do it by hand if you prefer to do it by hand. So let's try a couple problems. We are going to find the perimeter and the area of this figure. The dimensions are in meters. So I'm going to try to squeeze it in. I didn't leave myself too much space here. So let's see what we can do. So first thing we're going to do is we're going to find the perimeter. The perimeter is the lines that go around the entire thing. It's not the area inside. If you would just make this a string, a bunch of strings, and lay them out, that would be the perimeter. So when we go to do the perimeter, we're going to find this side. We're going to add this side plus this side plus this side, and we're going to do a half of a circle, half of the perimeter of a circle. So let's write that all down. So we have to do the perimeter. Remember, the perimeter is the distance around. So it's going to, like if you're putting baseboards in a room, that would be part of your perimeter. So let's add these up. So we're going to get 11.8. Perimeter is pretty easy, right? Plus 10. That's right here. And then we have our plus the 15. So we did the easy part first. We did the 10, the 11.18, whoops, 11.18. And then we did our 15. Now we do have to do a half of circle. Now remember, circumference equals 2 pi r. You need to memorize that. That's circumference. Divided by 2. So if we're going to find the circumference of this circle, it's just going to be pi times r. So let's just put this in here, plus pi. Let's just turn that into 3.14 times r, which is the radius, and that is 5. So perimeter is pretty easy. I said you can use your calculator. Yep, so you're just going to take, put this in, plus 10, plus 15, plus 3.14 times 5. You can put it all in at one time, and you're going to get the perimeter equals 51.88. The units are meters. When you're doing circumference, it's not square, it's just plain meters. Okay, that one was pretty easy, right? So you just find the circumference of a circle right here and you divide it by 2. and you get to use your calculator. Take a little pain out of it. All right, let's do the area. Area is a little bit harder. Now, in order to find the area, we need to divide the shape up a little bit. So I'm going to divide this into, just put a line, make it a triangle like that. So we have 3 figures we have to find the area of. We need to find the area of the triangle. This is going to be a square, and the area of a half of a circle. So let's see if we can find some of the missing parts before we start. So if this is 10, down here is going to be 10, and down here would be 10 plus 5. So this is going to be, we'll give you the 15. So this is going to be 5. And then the height. Let's think about how we find the height of this triangle. Well, if I took this radii and radius and I put it up here and I put it down here, it would be a 5 and a 5, right? It's still the same radius here and here. So this height is going to be 10. So you can see it is a square. All right, so let's do this. We're going to find the area of each part and we're going to add them together. So we only needed this number for the perimeter. So to find the area of the triangle, it's going to be 1/2, or base times height, divided by 2. So let's just do that. So it's going to be 5 times 10 divided by 2. So that's the area of the triangle. So it's going to be 50 divided by 2, going to be 25. So you can put it in there if you want, or you can just put it below. So the area is going to be 25 of the triangle. Okay, an easy one. Now we have the area of the square. So that's just going to be side squared, or 10 times 10. So that one's going to be plus 100. So we have 100 here. And then we're going to do pi r squared. So the area is going to be pi r squared divided by 2. This is where your calculator comes in pretty handy. So we're going to get pi. Well, let's change that to 3.14. Use 3.14, don't use the pi button on your calculator. 3.14 r squared, so r would be 5 squared divided by 2. Because it's half of a circle, we're going to find the area and we're going to divide it by 2, and that's going to end up being 39.25. So get all 3 of those numbers written down, and so we're going to have the area equals 164.25. Area is always units squared, so it's going to be meters squared. So there you go. It's a little tricky. This part right here is a little tricky. So you're going to take, it's pi r squared, the area of a circle, divided by 2. And that's where we got that. So it's pi 5 squared divided by 2. And you add it all together, and there's our area. Okay, we have one more of these, and then I have one for you to try. Okay, so we're going to find the perimeter and the area of this figure. Note we have 2 semicircles. All right, let's start with the perimeter. The perimeter is, we're just going to add everything up. Now you're going to be, this is part of your perimeter, your half circles. See the half circles like this? That's part of the area, the distance around the figure. So we can figure out the flat surfaces. So this one right here, a little tricky. This is going to be 4, 4, and 6. So this is going to end up being 10. That whole part. Well, let's not put that there. 10 is down here. All right, so this distance. So it's going to be your 4 and plus your 4. Okay, well, let's fix that up right. Okay, so it's 4 plus 4 is 8 plus 6 is going to be 14. Got a little distracted there. All right, this distance right here, if you straighten this radius up, it's going to be 5 that way, 5 down this way, so this side's going to be 10. All right, so we have enough to get started now. So let's add the 14 plus the 10 plus the 6. Don't forget this number right here. Now we have to do our half circles. Remember, circumference equals 2 pi r, and we're doing a half a circle, so half of a circle, we would divide it by 2, right? So it would be just pi times r. To get the half of a circle, we divide it by 2, it's just pi r. So let's get the circumference of the two half circles. So it's going to be pi, which is 3.14, times r, which is 4. I'm going to run out of room, so I'm just going to go on here, plus this half circle, which is 3.14, times r, which is 5. Your calculator can handle this if you just go from left to right. It does order of operations for you. And you just put it in your calculator, and you're going to get 58.26. Don't forget your units, and it's in centimeters. For perimeters, it's not squared. You must put your units on there, or you're going to get the problem wrong. Okay, area. A little bit easier, maybe a little bit harder, I don't know. So we have two half circles. So I'm just going to write it down. We have pi r squared, that's the formula for a circle, divided by 2 would be your half circle. Then we have another one of those. We have another pi r squared divided by 2 for the other half circle. And then we're just going to have our length times width. We have a rectangle right here. Length times width, so that's just going to be your 14 times 10. All right, let me go plug the radiuses in here. So the radii. So we're going to get 3.14, a little bit more complicated. Radius is going to be 4 squared. And then we have to divide that by 2 because it's a half a circle. Plus 3.14. The radius this time is 5 squared divided by 2. That's this half circle. And then we're just going to have our 140. Hopefully that didn't run off the page. All right, you're going to have to use your calculator and do each part of these complicated parts separately. So you're going to take 4 squared, which is 16, in your calculator, times 3.14. Then you say equal, and then hit divided by 2, and you're going to get 140. Okay, the next one. 3.14 times 25 equals divided by 2, and you get 25.12. And then we have our 140. All right, then you just add these all together, and you get 204.37 centimeters squared. Area is always squared because our formula is r squared. And it would be length times width, so you'd have centimeters times centimeters. So this is going to be your area. All right, tough one for you. I hope you have a calculator. So let's give it a try. Here we go. All right, I turned the page. Where is it? Here it is. Okay, so we're going to find the perimeter and area of this figure. Dimensions are in centimeters, and then you're going to find the area. So go ahead, turn off the video, try the problem, do the perimeter and the area, and then see if you got it right. Okay, I hope you did it and didn't just wait for the pause. You have to try it. If you don't try it, you won't know if you know it or not. Really important that you try it yourselves. Okay, so here we go. This is similar to the last one that we did. Let's do the perimeter first. Perimeter equals, we have, remember the formula for perimeter, 2 pi, not for perimeter, for circumference of a circle. Circumference equals 2 pi r, but we're doing half of a circle. So it's just going to be pi times the radius. So let's do those first. So we have pi, 3.14, times 2, plus 3.14 times 3, and then we need to get the sides, the flat sides. Okay, a little twist to this one. This flat side's 8. This flat side right here is going to be, if you stood the radius up, it would be 2 and 2, so it's going to be 4. And then if you laid the radius down both ways, you're going to have 3 and 3. There's 3 here, but there's 6 here, but there's 8 down here, so this has to be 2. So we did this one, we did this one, we did the 8. Let's do the 4, and then let's do the 2. Hopefully you got that one. So when you do all the work for this one, which I hope you did, You just enter it in your calculator and we get 29.7 centimeters. Not squared because it's just a length. Okay, area. So area, let's figure this out. So we have two circles, so it's going to be pi r squared. So pi was 3.14, and we have 1 is 2 squared, and we have to divide it in half because it's half of a circle. Remember, area equals pi r squared. All right, let's do the next circle. So it's going to be 3.14 times 3 squared over 2. And then we're going to add the little 2 and the 4 and the 8. Oops, never mind. We are doing area, not perimeter. So that's the area of the two circles. Now we have to do the area of the rectangle, which is just going to be 4 times 8. That's a little bit easier, right? So you put these all in your calculator. I think this comes out to be 6.28. Yeah, that's what it's going to be, plus 14.13 plus 32. Add those all together and you get 52.41 centimeters squared. Okay, you can either pause the video and do it tomorrow or watch both of these lessons at the same time. I'm just going to keep going here. Just makes it easier for me, less to upload to YouTube. Okay, so let's go on to lesson 65. Lesson 65 is a little bit easier. So it's proportions with mixed numbers and using proportions with similar triangles. So we've done these kind of problems before. We just have some mixed numbers in our fractions. So here we go. The first thing we're going to do is we're going to make our mixed numbers improper. So 4/9 over x equals 11/5 over, 11/5 over, I am doing this video late at night, 7/4. All right, we're going to cross multiply. It's a proportion. So if we had 2 over 3 equals 4 over x, remember these, we cross this way and we get 2x, and then we cross this way and we get 12, okay? That's what you're doing. But you have fractions. Don't let them scare you. So you can write them all out, makes it easier. So you're going to get 4/9 times 7/4 equals 11/5 x. Reduce if you can. Look at this. It makes it easier. Those divide into each other. So you have 7/9 equals 11/5 x. You can always switch sides if you want. You can say 11/5 x equals 7/9. That's totally legal because if you have the same people on the seesaw and if they switch places, they're still going to be balanced. Okay, so you're going to multiply both sides by the reciprocal, which is the same as dividing. When you divide, you flip the bottom fraction and multiply, so that's all we're doing. 5/11. These cross out. We get x equals 35 over 99. That was our first problem. All right. That was the only one, but we're going to have one in the practice problems. We've done this before, so they just added the mixed number. Okay, a new concept. If two triangles have angles with equal measures, the triangles are similar triangles. Sides opposite angles of equal measure are called corresponding sides. Corresponding sides of similar triangles have the same ratio. This is a big deal. This is our new thing. Corresponding sides of similar triangles all have the same ratio. So we say the sides are in proportion, and we can use proportions to find the missing lengths. So similar triangles do not have to be the same size, but all their angles have to be the same. And the way we mark it is the angles that are the same are called corresponding angles. And you can tell they're corresponding because they have 1 slash here. These two are corresponding because they have 2 slashes. And these are corresponding because they have 3 slashes. So the first thing, if the triangles are not lined up with the slashes, like in the same place. You need to rotate your triangles and make sure that they line up. Okay, the sides of similar triangles are proportional, which means we can write it like this. This side corresponds with this side. It's between the 1 and the 2. This side's between the 1 and the 2. So we can say 2 over 3 equals, now if we want to find x, we do left to right equals left to right. So it's going to be 4 over x. 2 over 3 equals 4 over x. And then it's a proportion, so we cross multiply. We get 2x equals 12. Divide both sides by 2, and we get x equals 6. Now we're going to do y. Now the only ones that have corresponding sides that don't have a variable would be 2 and 3, so we use it over again. 2 over 3. Now this time we want to get y, so we're going to do left over right, so we're going to do 5 over y. Cross multiply, we get 2y equals 15. Divide both sides by 2, and we get y equals, the beauty of algebra, 15 over 2. Those were the only examples, so let's go do the practice problems. I just copied them right out of your book. Okay, it might be a little tough to squeeze those in there. I'm going to give it a try. So go ahead, I want you to try A, and then come back and see if you got it right. So go. Okay, I'm going to squeeze A right in here. I'll do B below, I think. So first thing we want to do is change them into improper fractions. So this is going to be 7/4 over 2/3 equals 10. Let's see, oops, no, it's not 10. It's 21/4 over x. All right, cross multiply. So you're going to get 7/4 x equals, it's going to end up being, well, let's just do it. 2/3, whoops, a little blurry here, 2/3 times 21/4. So 2/3 times 21/4. So you do this way, right down here, you do this way, right down here. Okay, so the 3 goes into the 21 7 times. The 2 goes into the 4 2 times. Like that. And I knew I was going to run out of room, so I'm going to just squeeze it in here. 7/4 x equals 7 over 2. Okay, we're going to multiply both sides by the reciprocal, so this is going to be multiplied by 4 over 7. And we're going to do this side by 4 over 7. Couldn't really squeeze it in there. So we get x equals, this goes in 2 times, this goes into each other 1 time. So the final answer is x equals 2. Hopefully you got that one, did you? Okay, let's go on to example B. Just clean that right up, and I'll squeeze this one in too. Okay, go ahead, do example B, turn off, pause the video, and come back and watch this. All right, example B. So we make these improper. So it's going to be 13 over 4 over P equals 12/13 over 6 all over 32 over 10. Cross multiply, so we're going to get 13 over 4 times 32 over 10 equals 13/6 times P. I'm going to drop down into this little space over here. So can anything cross out? The 4 can go into the 32 8 times. That's it. Oh, no. Is that a 12 or a 13? I can't really read my writing right now. Okay, so we're going to get 8 times 13, which is 104. So we're going to get 104 over, oh, I think this reduces a little bit more. All right, hold on. We can take this down. Missed this here. So the 8 So we can take 2 into 8, so it's going to be 4. 2 into 10 is going to be 5. So we're going to take 13 times 4, and we get 52 over 5 equals 13 sixths p. Multiply both sides by the reciprocal. Again, I didn't save enough room. That 52 looks shaky, doesn't it? So we're going to take 52 fifths times the reciprocal, which is 6 over 13. And then we do it on this side too, and we get p. 52 divided by 13, that's good. That's 4. So this is going to go into this 4 times, and we're going to end up with p equals 24 over 5. That's the right answer. Okay. All right, let's do our proportions and we will be done. I can squeeze this down here. Proportions, similar triangles are kind of fun. Make sure they're lined up the same way. These ones are, we have 1, 2, 3, 1, 2, 3. They're similar triangles because all the angles are congruent to all the angles of this triangle. That means that the sides in between the angles are proportional. So we set up proportions. So we're going to do left to right, left to right. So we have the 5 and the 4 match up. So we're going to say 5 over 4 equals 9 over m. I just did that one first. 5 over 4 equals 9 over m. Make sure they match up. So cross multiply, 5m equals 36. Divide both sides by 5, and we get m equals 36 divided by 5. Now we have to go get the p. We're still going to use the 5 over 4 because there's no other pair that doesn't have a variable. So 5 over 4 left to right equals left to right. I forgot to tell you to do this problem. Darn. Okay, so we're going to cross multiply, so we get 5p. Hopefully you did it anyway, right? You know how this goes. So 5 divided by 5, and we're going to get p equals 28 over 5. There you go. Kind of tough lessons this week. Now I want to remind you of how to do your homework. For the odd lessons, I want you to do your practice problems. Do A. Check the answer in the back of the book. If it is right, move on. If it's wrong, redo the problem. Don't just go on. Then we do problem number 1. You do your problem, check it in the back of the book. If it's right, put a check and move on. If it's wrong, go back and fix it. If the problem is wrong, I want you to write on the top of your page. So if you're doing lesson 65, at the top of your page say, oh, I missed number 1. Put it up there so I can see it when I check your homework. Then do number 3. If it's right, check it, move on. Number 5, the same thing. If it's right, you check it, you move on. If it's wrong, you fix it until you get it right. If you try every way you can think and you still get it wrong, write the answer at the top of your page. That way we'll know. So I'll know who watched this video by who does their homework correctly this week. So if you want to still have your parents check the evens, that's great. If your parents still want to check it, that's good too. But I want you to get in the habit of checking each problem and making sure that you retry it and don't just move on. Okay, a lot of mistakes are probably just because you're rushing. So I want you to go back and try it and try to get each lesson done completely and accurately. Okay, that's it for this double video.